Hello 8th graders and welcome to Math Weekly number 6, where our focus skill will be on rational versus irrational numbers. Let's first begin by talking about real numbers. Real numbers are all the numbers that can be represented by our world. All real numbers can be written as decimals. There are two types of real numbers, rational numbers and irrational numbers. Rational numbers are all the numbers that can be written as a fraction. This includes integers, fractions, decimals that repeat, decimals that terminate, and perfect square roots. Irrational numbers are the opposite. They cannot be written as a fraction. This includes decimals that never repeat and never terminate, pi, and non-perfect square roots. Every real number is one of these two types. Now, we saw in that list perfect and non-perfect square roots. Perfect square roots are the ones that equal a whole number. Non-perfect square roots are the ones that equal a decimal between two whole numbers. This clock lists the first 12 perfect square roots. The square root of 1 is equal to 1 because 1 times 1 is 1. The square root of 4 is equal to 2 because 2 times 2 makes 4. The square root of 9 is equal to 3 because 3 times 3 makes 9, and so on around the clock, equaling each of the whole numbers that correspond to the clock locations. Every square root listed on this clock is considered to be a perfect square root because it equals a whole number. Knowing these perfect square roots can help you know the non-perfect square roots because they are between two whole numbers. So here are two whole numbers, 1 and 2. In between the square root of 1 and the square root of 4 is the square root of 2 and the square root of 3. These two are non-perfect square roots because they're between the square root of 1 and the square root of 4. So they're between the whole numbers 1 and 2. They're 1 point something. The square root of 12 would be another example of a non-perfect square root because it lies between the square root of 9 and the square root of 16. In other words, it's between 3 and 4. It's 3 point something. It's a decimal in between two whole numbers. So let's sort some rational and irrational numbers. We'll determine where they go and give a reason for why we're putting them there. So our first number is negative 35. Negative 35 is a rational number. Why? Because it is an integer. All integers are rational numbers. What about the square root of 49? Is there a whole number that I can multiply by itself to make 49? Yes, 7 times 7 makes 49. So this is a perfect square root. The square root of 49 equals 7. So it's rational because it's a perfect square root. 3/9. 3/9 is a fraction. All fractions are rational. In fact, by definition, a rational number is any number that can be written as a fraction. So 3/9 is a rational number because it is a fraction. The square root of 82. Is there any number that we can multiply by itself to get 82? If you're not sure, try them out. 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, we're getting closer, 8 times 8 is 64, 9 times 9 is 81, so the square root of 81 is 9, and 10 times 10 is 100, so the square root of 100 is 10. This falls in between these two whole numbers, so this is irrational because it's non-perfect. It's a non-perfect square root because it's between 9 and 10. Okay, well that one will not come up, but here is what it said. It said 5.352 with a repetition bar over the 352, which really means this continues on and on like 5.352, 352, 3.352, 352, and so on. So this is a repetition bar, which means that the decimal repeats. Decimals that repeat are rational numbers. So it's rational because it has a repeating decimal. What about the square root of 50? Well, let's see. Can we have a whole number that equals that? 6 times 6 is 36. 7 times 7 is 49. So the square root of 49 is 7. And 8 times 8 is 64. So the square root of 50 is in between 7 and 8. So that makes it a non-perfect square root. And all non-perfect square roots are irrational. And this one is specifically irrational because it's between 7 and 8. What about pi? Well, pi is 3.141592 and so on. It is irrational because it goes on forever and never repeats. It never stops and never repeats. Oops. What about this one? 2.814287 dot dot dot. That dot 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 means that it goes on forever. Is there any type of repetitive pattern here? No. So this is an irrational decimal because it goes on forever and never repeats. So same reason as here. So let's summarize what we've learned. Integers, like the number 8, are rational numbers. So are fractions, decimals that repeat, decimals that terminate, and perfect square roots. Pi and non-perfect square roots, like the square root of 2, are irrational because their decimal goes on forever without repeating.